Hello there. Hi, it's Tuesday, April 2nd. Uh, I switched spots where I've been setting up. I think I got a little bit better lighting here. At least I can see the board a little bit better in the thing, in the camera. First thing I want to say, if you can, all right, by next week, I'm going to suggest that you get these type of Alka-Seltzer tablets. What I think I'm going to do for next week, being we have to do a continuance of your educational process by the order of the Governor Andrew Cuomo, uh, I need you to get two packages like this. You have a week for it. I think Monday I'm going to give you instructions on how to do a lab with them. I'm actually going to give you the same lab sheet I would have given you in the classroom to fill out along with it to record your data and answer a few of the questions, and you could submit that back to me. On Monday, I'm going to provide you with the instructions because obviously you're not going to have beakers at home, but I'm going to give you containers that you can use to substitute, like three glasses of the same size and shape. You can use plastic cups, but I think glasses would work better, just like beakers work better than plastic cups when we're doing experiments in them. And I'll tell you how to use it. You're going to need two packages like this because you're going to need three Alka-Seltzer tablets. You're going to do one powdered, one whole in hot water, and then you're going to do one whole in cold water as a control. And you're going to see how the different variables like surface area and temperature affect reaction rate. We would have been able to do a concentration one, but that requires solutions that need to be added together, which you wouldn't have at home. But we can do the simple one with the Alka-Seltzer tablets. So you have a week, right? On Tuesday of next week, you're going to get a lab to do, right? Requiring two packages of Alka Seltzer. I'm sure at some point in time over the course of a week, uh, you know, I know we're running out of toilet paper in the supermarkets, but the Alka Seltzer tablets are uh, are in the stores, so you should be able to get them, or maybe you even have them in your homes already, or someone's home. So do your best, get them by next week, and then I'll instruct you on what to do on Monday. I'll send you the lab paperwork on Tuesday, and then you'll perform that Tuesday, and then we'll figure out Wednesday, Thursday, Friday next week what I can have you do at home that represents the lab, and it won't be as monotonous as sitting here listening to me for 20 to 25 minutes. But having said that, let me move on with the questions. I abruptly left you off with question number. I don't know if you can see, but by the way, I'm working next to Phoenix. That's our bearded dragon that we have over here. Um, he's an Inferno red bearded dragon, thus the name Phoenix uh, from Fawkes, the Phoenix that Dumbledore had. Anyhow, um, continuing on here, we left off. I cut off abruptly at 36 yesterday. My hard drive filled up, so at least I was able to upload and it saved what I had. But I wasn't going to restart again because I couldn't add and edit. So I just ended there, and it really doesn't matter because, like I said, we're working through next week, so it's all good. Starting with question number 37. We've seen this one before. I think we had it in our textbook. Oh, I'm actually also going to send you a link. The textbook is online. Some of you, I know people that didn't have it emailed me, and I actually dropped them off a copy at their house. I went to their house and dropped it off. Uh, so I'm assuming everyone else has it. But if you don't and haven't reached out to me telling me that you don't have it, I was emailed a link that has the textbook online. So if you don't, you can go there so we can continue to work with our textbook. Even if you don't have it, you have a link to it online. Like I said, they're making us do everything remotely, even get our textbooks because they don't let us in the schools. Number 37, a potential energy diagram is shown. Uh, which reaction would have the lowest activation energy? I actually think it was slightly different. It asked which would be the fastest rate. This one is asking for the lowest activation energy, which would have the fastest rate. The answer would still be the same. The forward catalyzed reaction. So the answer is A. Number 38. Given that reaction diagram, reaction pathway, reaction mechanism, whatever you want to call it, potential energy diagram, which letter represents the activated complex? That would be B, the top of the hill. Number 39. Okay. Which equation represents chemical equilibrium? Uh, choice two rather, B represents the chemical equilibrium because the formulas on both sides are different. A, C, and D are phase equilibriums, right? Like choice A, it's nitrogen on both sides. Nitrogen is a liquid, nitrogen is a gas. Number 40, when a reversible chemical reaction is at equilibrium, the concentration of the products and the concentration of reactants. The obvious answer that you're going to jump to right away when reading this is going to be choice D. You're going to say, ooh, D equal, equilibrium equal. No, rates are equal at equilibrium. The amounts are constant, so it's C. Amounts are constant, rates are equal. Number 41, which changes can reach dynamic equilibrium? Chemical and physical changes reach equilibrium. Nuclear has no equilibrium, it's only forward reactions. Number 42. Which statement describes a chemical reaction at equilibrium? Okay. The concentrations of products and reactants are constant. D. Right? Again, amounts are constant, rates are equal. Okay. Number 43. Given the reaction diagram in a closed system, notice the stopper. That's why it can go to equilibrium. Without a stopper, the liquid water would continue to evaporate. The evaporated molecules would leave the container, and we don't have equilibrium. Once we stopper it, equilibrium is possible. Okay. D, the rate of evaporation equals the rate of condensation. Those are rates. Rates are equal. Right? The masses aren't ideal. Like A says the mass of H2O equals the mass of H2O, liquid and gas. Not true. The rates are equal. The amounts are constant. Looking at the size of the flask, you're going to have much more liquid molecule present than gas molecule because gas molecules are so spread out. Okay, 43 is D. 44. Given the equation in the closed system, which statement describes the system at equilibrium? C, the rate of the forward reaction equals the rate of reverse. Okay. Number 45. Given the reaction representing a system at equilibrium, okay, at equilibrium, the concentration, so those are amounts, B, must be constant. 46. Which two factors must be equal? It's got to be rates. Something says rates if it says what's going to be equal, because amounts aren't going to be equal. The rate of the forward and the rate of the reverse, which is letter C, will be equal. 47. A chemical reaction at equilibrium comparing the rate of the forward and reverse, right, would be D. The same, and the reaction continues in both directions. The forward reaction and the reverse reactions both occur simultaneously and at the same rate. Right? 48. Some solid KNO3 remains at the bottom of a stoppered flask. Right? Right? Lost my place. Some solid KNO3 remains at the bottom of a stoppered flask containing saturated KNO3 solution. Okay, explain why the contents of the flask are at equilibrium. The rate of dissolving, right? So it continues to dissolve. The little bit that remains at the bottom of the flask continues to dissolve, and then some of the crystallized, some of this KNO3 in the solution crystallizes again. It dissolves, crystallizes, dissolves, crystallizes, back and forth. That's equilibrium. 49. Given the equation representing the system at equilibrium, at what temperature does this exist? Solid liquid, that's freezing and melting, melting and freezing, they occur at the same temperature. That would be B, 0 degrees Celsius. The 273 number, which is choice D, that would be in Kelvin. 50, which represents a phase equilibrium. Uh, A and B are clearly chemical, okay, because we have different formulas on both sides. C is your answer. D is tricky. It almost looks like some sort of a phase equilibrium, but it's O2 and O3, oxygen to ozone. So even though it's the same element, they're different chemical formulas of one another. Okay, so that's chemical, not phase. Number 51. Which description applies to a system in a sealed flask half filled with water? Right. D. Both evaporation and condensation are occurring. Number 52. The vapor pressure of a liquid at a given temperature is measured when the rate of evaporation, it's a closed system, so it's at equilibrium. Evaporation will equal the rate of condensation, C. Okay? They are equal, rates of opposing reactions. 53, right? Solution solution equilibrium is reached in a system when, right, both dissolving and crystallizing occur at the same rate. Dissolving occurs at the same rate as crystallization. That's D. 54. Given the equation representing a reaction at equilibrium, which change will favor the reverse reaction? Okay, this system is initially at equilibrium. We're going to shift the equilibrium. This starts going from system at equilibrium to Le Chatelier's principle, shifting equilibrium or changing equilibrium. So given the system which is currently at equilibrium, which change will shift it left? The reverse reaction is going to the left. Forward is from the left to the right, shift right. Reverse is from the right side to the left, product side moving to reactant side. And let me first look at choice D. It says pressure. This reaction will not be affected by pressure because there's two gases on either side. H2 and I2, those are both gases. Okay. 2HI is 2HI in the gas phase. So there's an equal number of gases on either side. Now, let's look at choice B. Increasing the temperature. Remember we said increase in temperature, move away. If I increase the temperature, that's going to move to the right. Therefore, decreasing the temperature would move it to the left. Okay, so the answer is B. Okay. If we look at A, let's look at the correct answer is B. I'm going to also look at A and C. So we review shifting a little bit, and then some of the other ones I can go through a little bit more quickly on the shifting or the Chatelier's principle. If I look at A, it says decreasing HI. Well, I gave you the rule for increasing, so let's look at increase and then reverse it for decrease. If I increase HI, it's going to move left. If I decrease it, then it's going to move to the right. So it's not that. And the last one, C, it says increasing I2. Increasing I2 would move it right. We want the one that goes left. B is the only one that's going to go left. That's the answer. Number 55. Which will result in an increase in temperature, right? 55, increase in temperature, move away from heat. So if I increase the temperature, it's going to move right. The heat's on the left, so it's going to go to the right. So we have choices C and D, say right. If it moves to the right, NO2 will increase. Your answer is D. 56. Given the reaction at constant pressure, okay, when the temperature is increased, this 2 will shift right because the heat's on the left. Increasing the temperature is going to move it right. And moving it to the right, HBr will decrease. So that's A. Number 57, given the reaction at equilibrium in a closed system, what will be the result of an increase in temperature? Same thing, increasing in temperature. We'll take the reaction and shift it to the right. And in shifting it to the right, HI will increase. Right? And number 58, given the equation representing a reaction at equilibrium, which change will cause the equilibrium to shift to the right? This is a pressure one, okay? Actually, no, increasing the pressure. I'm wrong. The answer is C. Increasing the N2 will shift it to the right, making the NH3 more, which it didn't ask about. 59. Okay. Which change, given the system at equilibrium, which change occur when O2 is added to the system? If I add O2, it's going to shift the equilibrium to the left, okay? And that's going to cause the PCl3 to decrease. Let me diagram this one out because this one is probably a little bit more confusing than the other ones. It was straightforward. They're adding something to the right side of the equation, which is going to cause the other thing on the right to decrease. So one's increasing and decreasing. One is increasing because it's being added artificially. It's being added from an outside source, which causes the one on the same side to decrease. It does obey all our rules, but let me diagram it out. That equation says 2POCl3. So it's 2POCl3 in equilibrium with. I'm ignoring the energy because we don't need it to answer this question. 2PCl3 plus O2. All right, that's our balanced chemical equation. I left the energy out of it. Okay, now it says I'm adding more O2. So this is added. Okay, I'm adding more O2. Okay, I'm adding O2 to that. Since I'm adding more O2, we're going to move away from what's added, which is going to drive the reaction to the left. That's going to make everything on this side less, everything on this side more. So the PCl3, that's on the side that's less, that's going to decrease. Okay, so the equilibrium is going to shift to the left, and the PCl3 is going to decrease. The answer is D. Now, the O2 and the added O2, those actually decrease also, but there's still going to be more of it because I added extra. Okay. Number 60. Given the reaction at equilibrium, which change will result in a decrease in the amount of NO? To decrease the NO, it's going to have to shift left. So if I write this one out too, N2 plus O2 in equilibrium with 2NO. Important to note here right away, the number of gases on each side are 2. There's 1 N2, 1 O2, and 2 NOs. They're all gases. So we want NO to decrease, which change will result in a decrease in NO. So we want it to go this way so that this side becomes less and this side becomes more. And we want to know which choice results in that. Okay. It's going to be, if I decrease the N2, right? Actually, B and C are opposites because the N2 and the O2 are on the same side. I'm going to look at choice C first. If I increase the O2, it's going to shift to the right. I don't want that. I want it to shift to the left. If I decrease the N2, if I increase the N2, it's going to go right. If I decrease it, then it's going to have to go left. I'm going to have to replace the N2 that I took away. In order to replace the N2 that I took away, it's going to have to come from the NO. So the NOs are going to be less to replace the N2. Removing the N2 creates a stress, driving the reaction to the left. To alleviate that stress, the NO is going to break down. I'm going to get more O2, and I'm going to replace some of the N2s that I lost. 61. Given the reaction at equilibrium, the concentration of the product could be increased by, right? The product is Z. I have to add X and Y to make Z. So the answer is C. Number 62, given the Haber reaction, what stress, it's called the Haber reaction, it produces ammonia, it doesn't affect anything. But which stress on the system will decrease the production of NH3? Okay. C, decreasing the H2. would shift it left. It needs A and C are opposite answers here. H2 and N2 are on the same side. A would give you more NH3. C would give you less NH3. The answer is C. 63, given the reaction at equilibrium, okay, the addition of a catalyst. Remember, a catalyst gets you to equilibrium faster. It makes both your forward and reverse reactions increase equally. So a catalyst does not give a shift. Okay, it's basically constipated, right? It doesn't shift your equilibrium. Okay, so it'll increase the rates of the forward and reverse reactions equally. That's why they do not give a shift. 64, the addition of a catalyst to a system that is at equilibrium, C again, both the forward and reverse reactions are increased. So 63 and 64 are both C. Right? 65, given the reaction at equilibrium, which change will shift the equilibrium to the right? Okay, B, increasing pressure. There are 3 gases on the left, only 2 on the right. Increase in pressure, go to the side with less gases. So that's B. 66, given the reaction at equilibrium, if the pressure on the system is increased, what's going to happen to the Cl2? Someone had asked me a question about this. I talked about it very briefly yesterday. There are 5 gases on the left, 4 gases on the right. Increasing pressure is going to shift it to the right. The right side, everything on the right side is going to be more. The Cl2 and the H2O both will increase. It's asking about the Cl2, so the answer is B. 67. When pressure on the system is increased, the concentration of SO3, 66 is the same as 67. Increasing the pressure, it's going to move it to the right because there are less gases on the right. So it's going to go to the right, and SO3 will B increase. 68. Given the reaction at equilibrium, an increase in pressure, same thing. It's going to shift to the right. 3 gases on the left, 2 gases on the right. 69. When the system, which system will be least affected by pressure? Okay. C. C is not going to be affected by pressure. You know why? There are no gases present. Gases create the equilibrium effect with pressure. Pressure only affects gases. And the last one for today, which system will pressure have, which effect, sorry, I can't read right now. Which effect will an increase of pressure have on the system? So 4 gases on the left. We have N2 gas and 3 H2 gases, so that's 4 gas moles, and then 2 NH3 gases, 2 gas moles. So an increase in pressure is going to go to the side with less gases, which happens to be the right. By coincidence, all of these have had less gases on the right. It's just a coincidence. It doesn't have to be. But for the ones that I have listed here, yes, they are driven right with increases in pressure. It's not all the time. It just happens to be that these 4 questions did the same thing. Which effect will have an increase in which effect will an increase in pressure have on the system? So the N2 and the H2 are going to decrease, and the NH3 will increase. So the answer is going to be C, an increase in the NH3 and a decrease in the N2, because that's what happens when it goes right. I think that's enough for today. I'm going to finish the last 10 tomorrow in the morning, and then post your test shortly after that. You'll have to take the test, you know, at your earliest convenience. I know there's less of a deadline when you're doing things with regard to remote learning, but I'm going to post it Wednesday. You're expected to post it Wednesday. If for whatever reason Thursday and Friday are going to be religious days for you, then you have to take it Wednesday. If you're starting a Passover celebration Wednesday, and then maybe you can do it Thursday, like you're going to have to figure out a time to do it during those days, okay? But it will be posted on Wednesday. All right. Uh, have a good day. Talk to you soon.